Imagine looking up into the night sky, at a single faint red star just 6 light-years away, and realizing it hosts not one, but 4 mysterious worlds, each smaller than Earth, each a new piece in the puzzle of our cosmic neighborhood. Today, we're about to unravel the story of Barnard's star and the 4 tiny, sizzling hot planets spinning tightly around it. What these discoveries mean for the search for life, for technology, and even for our future as an interstellar species might surprise you. Let's start at the beginning. For decades, astronomers have scoured the cosmos with increasingly sensitive technologies, hoping to find planets circling other stars, worlds that could reshape our understanding of how common or rare Earth-like conditions really are. For a long time, what we found were, frankly, cosmic oddballs, massive gas giants, so-called hot Jupiters frying close to their stars, or super-Earths that dwarfed our home planet in size and mass. But new technology and relentless human curiosity are changing that fast. In the 1960s, a strange rumor swept through astronomical circles. A planet might exist around Barnard's star, one of our sun's closest neighbors. Yet telescopes of the time simply weren't up to the task. The detection turned out to be a mirage, a cautionary tale about humanity's eagerness to find another Earth, sometimes seeing patterns where there are none. As technology advanced, so did our ambitions. We wanted not just to theorize about exoplanets, but to find them, measure them, and someday, even visit them. Barnard's star, a red dwarf burning with a steady but dim light, became a symbol of tantalizing astronomical promise. Located just 6 light-years from us in the constellation Ophiuchus, it's the nearest single-star system to Earth. Unlike Alpha Centauri, which is a triple-star system, Barnard's star shines alone, an ideal canvas for planet-hunting instruments. But the star is old, over 10 billion years, and not exactly inviting. Its red glow is faint, and it's noticeably cooler than our sun. Yet precisely for these reasons, it became a focus for scientists eager to test the limits of their detection tools on the smallest, faintest targets. Why? Because red dwarfs are the most common stars in the galaxy. If planets, especially small ones, can form and survive around such stars, then the universe might be filled with billions of little worlds, even if many are nothing like Earth. Enter the latest chapter in this cosmic story, the discovery of not 1 but 4 sub-Earth-sized planets tightly circling Barnard's star. This wasn't just a lucky find, it was the result of decades of tireless refinement in our ability to read the subtle fingerprints planets leave on their parent stars. By combining data from 2 of the world's most precise planet-hunting tools, the Maroon X spectrometer on the Gemini North Telescope in Hawaii and the Espresso instrument on the Very Large Telescope in Chile, astronomers were able to confirm what was once just a tantalizing hint. Here's how they did it. Rather than looking for the telltale dimming of starlight that occurs when a planet crosses a star's face, the so-called transit method, researchers tracked the star's gravitational wobble. As planets orbit a star, their gravity pulls ever so slightly on the star itself, causing it to move ever so subtly back and forth. By observing minute shifts in the color of Barnard's star's light, astronomers could measure these wobbles, revealing the presence, mass, and even the orbits of the unseen planets. It's a bit like hearing the footfalls of an invisible dancer, and deducing not just their presence but their size and rhythm. The results, recently published in the astrophysical journal Letters, stunned even seasoned planet hunters. Each of the 4 planets is a cosmic lightweight, just 20 to 30% the mass of Earth. That makes the smallest of them the tiniest exoplanet ever discovered using the radial velocity method. And the orbits? Blisteringly fast. Some complete a revolution in just a handful of days, so close to Barnard's star that their surfaces are scorched far too hot to support life as we know it. Let's pause for a moment. Imagine what that means. In a pocket of space barely a millionth the size of our own solar system, there are 4 rocky worlds, each so small and so close to a faint star that, even a decade ago, their existence would have seemed almost impossible to confirm. Yet thanks to advances in astronomical technology, we can now not just detect them, but begin to study their makeup and the forces that shape them. Dr. Suvrath Mahadevan, the lead scientist behind the Maroon X instrument, sums up the mood among astronomers. With Maroon X, we are pushing the limits of what is possible. Detecting Earth-mass planets around nearby red dwarfs isn't just a technical milestone. It's the first step toward understanding whether these worlds might offer clues about life elsewhere. But before we get ahead of ourselves, These planets are almost certainly far too hot for anything resembling life on Earth. The searing proximity to their parent star means their surfaces might be scorched, their atmospheres, if any exist, blasted by stellar winds. Yet even this is cause for excitement, because the discovery proves, for the first time, that our instruments are now sensitive enough to find tiny, rocky planets around the most common stars in the galaxy. The diversity of planetary systems is turning out to be far greater than anyone imagined just a decade ago. As Dr. Lisa Kaltenegger of Cornell University remarks, even if these worlds are uninhabitable, they force us to confront the sheer diversity of planetary systems in our galaxy. We're only at the beginning of understanding just how alien and how familiar other worlds can be. So what, you might ask, makes the detection of these 4 small, scorching planets so important? First, it's about numbers. Until recently, most of the nearly 5,000 exoplanets cataloged were giants, planets many times heavier than Earth. Why? Because large planets are easier to find. The gravitational wobbles they induce, or the shadows they cast during transits, are simply bigger. But if sub-Earths can be reliably detected around even faint, quiet stars like Barnard's, it suggests the galaxy could be teeming with rocky planets, many of them as small or smaller than our own world. Second, the proximity of Barnard's star means these planets are among our very closest neighbors, cosmically speaking. They're close enough that, within the lifetime of someone born today, we could conceivably send robotic probes to take direct measurements. It's not just theory. Ambitious organizations like Breakthrough Starshot are already developing technology that could, in a few decades, send tiny spacecraft at a fraction of the speed of light towards such systems. The possibilities for planetary exploration are transforming from science fiction to near-future engineering. But there's another deeper layer to the story, one that touches on our deepest questions about the cosmos and our place in it. For centuries, humanity has wondered, are we alone? Does life, or at least the chemistry that could spawn it, exist elsewhere? As Dr. Sarah Seeger at MIT puts it, the keys to finding life beyond Earth rest in our ability to characterize the atmospheres of small exoplanets. Each discovery, no matter how uninhabitable the planet, is a stepping stone. Yet there are obstacles. Barnard's star is old, over 10 billion years. Its planets have likely endured eons of stellar radiation, tidal locking, and atmospheric loss. According to Dr. Eric Gaidos of the University of Hawaii, tidal locking around red dwarfs poses significant challenges for habitability. One side of the planet can become a perpetual furnace, the other a deep freeze. But if an atmosphere exists and circulates heat efficiently, temperature extremes might be tempered. That's a big if. The planet's close orbits mean they're bombarded by powerful stellar winds that could strip away any nascent atmosphere. But astronomers are gearing up to find out. The forthcoming Extremely Large Telescope, ELT, and its high-resolution Andes instrument could soon analyze the atmospheres of even such faint, small exoplanets. High-resolution spectroscopy will be crucial for probing these planets' atmospheres and possibly even searching for biosignatures, says Dr. Ignace Snellen of Leiden University. For now, these 4 planets orbiting Barnard's star remain enigmas. Are they featureless, rocky cinders, or do they host exotic atmospheres and weather patterns unknown in our solar system? As Dr. Avi Loeb of Harvard provocatively asks, future interstellar missions might even search for technosignatures, evidence of alien technology, or map the geology and climate of these worlds up close. But all of this raises deeper questions. If the universe abounds with small, rocky planets, many in environments hostile to Earth-like life, what does that mean for our search for a second Earth? Have we only begun to grasp the true diversity of planetary systems, or are we still blind to the strangest possibilities fate and chemistry can produce? And here's the most tantalizing question. Could our success in finding Barnard's star's rocky, forbidden worlds be the prelude to discovering a planetary neighbor that isn't just strange, but habitable, or even inhabited? In the next part of this story, we'll dig even deeper into how astronomers are preparing to launch the next era of planetary exploration, what makes these planets so scientifically valuable despite their harshness, and how, just maybe, technology could bring us closer than ever to understanding our place among the stars. But first, imagine the possibilities. What secrets are locked within these 4 tiny worlds, and what will it take to uncover them? The discovery of 4 sub-Earth hot rocky planets around Barnard's star might, at first, sound like a footnote in the grand cosmic story. After all, these worlds aren't little blue Edens with gentle breezes or oceans, at least not as far as we know. But what if these harsh, scorched planets are actually the first stepping stones on our road to finding life elsewhere? What if, by understanding them, we unlock the secrets to spotting truly habitable planets, or even, one day, finding our cosmic neighbors? That's where the real intrigue begins. Picture Barnard's star, a red dwarf, ancient and flickering, its light crossing a mere 6 light-years of space to reach us. Now, picture 4 worlds, each orbiting so close that their years last only days. Radiation bathes their surfaces. Atmospheric conditions, if they exist, would be nothing like Earth's. Yet each one represents a triumph of human technology and ingenuity. Why should we care about worlds that seem utterly inhospitable? The answer, according to Dr. Lisa Kaltenegger of Cornell University, is simple yet profound. Even if these planets are uninhabitable, they force us to confront the sheer diversity of planetary systems. The implications are enormous. First, this discovery shatters our expectations of what typical planetary systems look like. The universe doesn't build only solar systems with Goldilocks planets. Instead, it sculpts a wild mosaic, some worlds like ours, many more wildly unlike it. By observing these extremes, we're rewriting the rulebook on what to search for in the cosmos. But that's only the beginning. Thanks to instruments like Maroon X and Espresso, scientists have pushed the limits of the radial velocity technique, measuring the wobble in a star's light as tiny planets tug on it. This is the first time researchers have reliably measured exoplanets with only a fraction of Earth's mass, orbiting a star just next door, cosmically speaking. Dr. Suvrath Mahadevan of Penn State puts it this way: "We're finally opening the window to Earth-mass planets around the most common stars in the galaxy. And the more we refine these methods, the closer we come to finding potentially habitable worlds, in the so-called habitable zone, where liquid water might persist." But what about these specific planets? They're baking under fierce heat, likely with locked day and night sides, one hemisphere scorched by perpetual daylight, the other in endless darkness. It might sound hopeless for life, but as Dr. Eric Gaidos of the University of Hawaii reminds us, tidal locking around red dwarfs poses challenges for habitability, but atmospheric circulation could mitigate temperature extremes. In other words, what seems a dead end today may, with deeper study and better models, reveal surprises in the future. Perhaps, beneath a thick, swirling atmosphere, even a roasting planet could harbor temperate regions, maybe not for humans, but possibly for life as yet unimagined. Future scenarios are tantalizing. Over the next decade, astronomers plan to use the Extremely Large Telescope and its Andes spectrograph to probe the atmospheres of these planets for the first time. Dr. Ignace Snellen from Leiden University is optimistic. High-resolution spectroscopy will be crucial to probe these planets' atmospheres for biosignatures. Imagine peering from Earth into the skies of a planet 6 light-years away, hunting for the ghostly fingerprint of water, oxygen, or even methane. If signs of complex chemistry are detected, the chase for life will shift from the realm of science fiction to scientific fact. And the future holds even bolder ambitions. Harvard's Dr. Avi Loeb envisions missions that could, one day, send probes to Barnard's star, perhaps small, laser-driven spacecraft capable of interstellar flight within a human lifetime. Directly imaging the surfaces of these planets, or detecting artificial signals, so-called technosignatures, would be the ultimate game-changer. Yet it's not just about distant, hypothetical missions. The tools and techniques being developed to detect these small, hot worlds have immediate consequences for planet hunting closer to home. With each new advance, astronomers are getting better at filtering out the noise of starlight, sifting through cosmic data to pick out signals corresponding to Earth-sized planets in their stars' habitable zones. Consider this. Until recently, most exoplanets found were either gas giants or super-Earths, planets larger than our own. With the confirmation of planets as small as 20% to 30% Earth's mass, we're now at the threshold where, statistically, Earth twins could be hiding in the data, just waiting to be revealed. So, what does this mean for you, sitting here possibly dreaming about other worlds? First, it reminds us that discoveries in deep space almost always have ripple effects back on Earth. The challenge of detecting planets orbiting distant stars inspires advances in optics, data analysis, and computing, technologies that often find their way into navigation systems, medical devices, or communications infrastructure. But there's a more personal lesson. The discovery of strange, uninhabitable planets is a humbling reminder of nature's creativity. It pushes us to keep searching, to keep questioning. As Dr. Sarah Seeger of MIT says, Characterizing the atmospheres of small exoplanets is key to finding life beyond Earth, and this discovery is a step forward. We're learning, piece by piece, to recognize the fingerprints of life across the universe. Studying how atmospheres evolve under fierce stellar winds, how planetary surfaces and climates react to tidal locking, gives us a better sense of what to look for when we finally spot a world that sits in the sweet spot. Not too hot, not too cold. And there's another angle. The confirmation of these planets around one of our nearest neighbors means that the galaxy is probably teeming with planets, even though most of them, statistically, will be uninhabitable. Still, with hundreds of billions of stars, even the tiniest sliver of habitability adds up. The odds of finding life, or a place we could one day visit, just got exponentially better. For school kids, hobbyists, or science fans, this is a call to curiosity. The universe isn't obliged to make sense in terms of our preferences. It will be full of surprises. Learning about the extremes only sharpens your eye for the familiar and prepares you to spot the extraordinary. Perhaps the next leap forward in exoplanet science will come from someone watching this video, inspired to join the search. Meanwhile, new missions are in the works. NASA's Roman Space Telescope, ESA's Plato, and the James Webb Space Telescope are all designed to push further, searching for atmospheres, climate indicators, and chemical signatures that might betray life. Thanks to the Maroon X and Espresso breakthroughs, these telescopes will know where to look and what to look for, with ever-increasing precision. Here's a secret. Barnard's star, for all its fame, was the subject of a famous false alarm in the 1960s. Astronomers thought they found a Jupiter-like planet, only to realize it was an error. Today, with new technology and relentless cross-checks, we're avoiding past mistakes and uncovering even tinier, stranger worlds. The lesson? Science is a journey, not a destination. Each step, even the missteps, brings us closer to the truth. So, let's circle back to our main question. Can studying these harsh alien worlds actually bring us closer to finding habitable or even inhabited planets? The answer is a resounding yes. By pushing the limits of detection and understanding how planets form and evolve in extreme conditions, astronomers are building the toolkit to recognize the rare jewels, worlds with the right conditions for life. We're not just cataloging numbers. We're learning what makes planets tick, what matters, what's just chance. Every rocky, broiling planet around Barnard's star is a clue, a lesson, a preview of discoveries to come. Soon, when we stumble upon a world with the right ingredients, not too far, not too close, with signs of water or perhaps oxygen, we'll know exactly what we're seeing. Until then, the sky is no longer the limit. The next chapter in the search for life isn't light years away. It's right here, right now, as we peel back the veils of cosmic mystery, one planet at a time. If you found this exploration fascinating, or if you have your own ideas about where to search for life next, leave a comment below. What would you ask an alien neighbor? What do you think we'll discover in the next decade? Are we alone, or are these discoveries inching us closer to cosmic company? Don't forget to subscribe for more deep dives into the biggest mysteries in our universe. Hit the bell so you don't miss our next adventure into the frontiers of science. And remember, somewhere out there, in the quiet light of a